Hi and welcome to Clean Architecture with ASP.NET Core 2.2. My name's Jason Taylor. I'm a solution architect for SSW. You can find me on Twitter at JasonGTAU or on my blog, codingflow.net. I try to blog once a week, that's my goal. I last blogged in September of 2018, but I'm trying. I've been developing now for 18 years and I've learned the most important principle is KISS, or keep it simple stupid. And this principle states that systems should be made simple rather than more complex. Today, I'd like to show you the simplest approach to developing enterprise architecture with clean architecture. Let's get started. So with clean architecture, the domain and the application layer are at the center of the design. The domain contains enterprise logic and types, and the application layer contains business logic and types. What's the difference? Well, enterprise logic would be used throughout multiple systems, whereas the business logic would typically just be used by this system. Together, the domain and the application layers make up the core. Now, rather than have core depend on concerns such as data access and persistence, we invert those concerns. So infrastructure, persistence, and presentation all depend on core. Now, we achieve this by adding interfaces or abstractions to core, which are implemented in layers outside of core. So for example, if we wanted to implement the repository pattern, we would add an iRepository interface inside core in the application layer, and that would be implemented within persistence. Now, with clean architecture, all dependencies point inwards. Presentation, infrastructure, and persistence all depend on core, but not on one another. And that's very important. This results in an architecture and design that is independent of frameworks. It doesn't require the existence of some library. It's highly testable. We can test all of core without the need for a database, a web server, or a UI. We can unit test it all. It's independent of the UI. That's a great place to be. Right now we're building a lot of web applications, maybe with Angular, React, and Vue, and they change very frequently, so we want that independence. Pretty soon we're all going to be writing Blazor apps anyway, because we don't like JavaScript. You like JavaScript? Not me. I don't like JavaScript. I know this guy, and this guy doesn't like JavaScript. It's also independent of the database. So we use SQL Server, we use Postgres, we use Oracle, but eventually we're going to be switching to Cosmos DB because it does everything. And it's independent of anything else external. In fact, core doesn't know anything about the outside world. And that's what makes clean architecture great. It's the design that will be there in 15 to 20 years' time, even though everything in the outside world has changed. Now you can see that in this particular design, there's only 3 layers, but you can change that. You might have a simpler requirement and you could use 2 layers, or you can use more. You just need to remember that those dependencies always point inwards. Let's have a look at an example. So my example is Northwind Traders. So show of hands, who's heard of Northwind Traders? Okay, 75% of the room. And I know what you're thinking, Northwind Traders is not cool, but you're wrong. I've upgraded it. It's now cross-platform. So it doesn't matter if you're running Windows, Mac, or Linux, you can run Northwind Traders. It's running on NetCore 2.2. It's running with Entity Framework 2.2. It's code first, and it's fully seeded. Sound cool? Yeah, Northwind Traders is cool again. Let's have a look at a demo. So this solution's on GitHub, and I have a link to the code and slides at the end. But let's have a look at the makeup. Slide deck? Oh, thank you. There we go. Okay, so you can see the solution's split up into a number of folders, but here in the source folder, we have our core, which contains the domain and application layer. We'll shrink that. We have infrastructure, which contains a standard infrastructure project and a persistence project. And we have a presentation project, which is a web UI. That's currently a single-page application built on Angular with .NET Core. In common, we just implement our cross-cutting concerns. You'll also note in the solution that I've added readmes and different projects so you can learn exactly what goes into each layer, and the slide deck's right there. Okay. Oh, skip through that. So key points. Domain contains the enterprise-wide logic and types. That's the logic that can be used across multiple applications. It's not typically shared. The application contains business logic and types. That's the logic that's specific to the application that we're building. Infrastructure, including persistence, contains all external concerns, and presentation and infrastructure layers depend only on application and not on each other. That's a really important point. If we did have presentation dependent on infrastructure, say to send some notifications or something like that, that forces us to add logic to presentation. And we really want that logic to be in core, where we can test it independent of anything external. Finally, infrastructure and presentation components can be replaced with minimal effort. So now we're going to look at each layer in turn, starting with the domain layer. In the domain, what would we expect to see? So we'll see entities, value objects, enumerations, logic, and exceptions, custom exceptions. Let's have a look in the domain. Oh, I'll have to, there we go. Okay, so I want to look at a few different things in turn. We'll start with this customer entity that I have. If we look at this customer entity, you can see that we're using data annotations throughout. And my recommendation is to use data annotations sparingly. You don't really want to include these in your domain model because it's not part of the domain. It's really a persistence concern. It's telling the ORM how to map these entities to the relational model. So we try to keep those out. Next, I want to talk about value objects. So with value objects, we basically create a simple entity that doesn't have an identity. A value object is equal to another value object if it has the same value. So with something like an AD account, we could easily encapsulate that as a primitive type, as a string. But an AD account is not a string. It's a complex object with specialized rules in the way that it's used. And when we use it, we typically need different information from it. Sometimes we'd like to see the domain, sometimes we'd like to see the username, sometimes we'd like to format it for display. So by including it as a string, we don't have a good place, at least, to encapsulate that logic. If we create a value object, we can encapsulate that logic. And that makes it easy for developers to see how to use that. So let's have a look. In the value object, I'm able to construct an AD account by passing in an account string. I can split it up into the domain and the name, and if something goes wrong, I can immediately throw an AD account invalid exception. I can access the domain and name quite easily, and I have a number of operators for working with the AD account object, which makes it quite simple. I have some tests which are a really good demonstration of how to work with it. So you can see this test is quite simple. It just says it should have a valid domain and name given a valid account string. This one, toString, returns the correct format, so we're expecting it to be SSW/JSON. Simple. The implicit conversion to string results in correct string. So we can take a string and we can say an AD account for that value returns an AD account, which is fine, but then we can implicitly convert this AD account value object back to a string just using the equals operator. So that just makes it easy to work with the AD account if we do want to display it. Then we can explicitly convert from a string to the domain and name. So you can see we take a string and just cast it directly to the AD object. Very simple, AD account. And we have our custom exception there. So when you're using primitive types, think about the type of information you're storing. Is it really a primitive type? Is it really a string? Is it really an integer? Or is it a little bit more complex than that? Are there some rules that you need to associate with that information that will make it easier for developers to work with your system? Because by doing that, you force them into the pit of success. You make it easier for them to do the right thing and hard to do the wrong thing. Another recommendation I have for the domain is to initialize all collections. So if we have a look at this order class here, you can see that right at the start, I'm initializing the order details with a default value. And down the bottom, I've actually got a private setter on that. So you're not going to be able to reinitialize it later. So what does that mean? It means it's always ready to use. We're not going to have code in the system that says, if order details equals null, then initialize. That's really common. We see it all the time, especially from new developers. Now, what's going to happen is it's always going to be ready. It doesn't matter if you've newed it up yourself or if it's come back from Entity Framework, it'll be ready to go. And if a new developer joins the team and they try to initialize it, they're just going to get an error. And they're going to see that, oh, this is the way that we're doing things, and that's pretty cool. That's helping them into the pit of success. So finally, and we looked at this briefly, within AD account, I have a custom exception. And it's good to use custom exceptions in the domain when necessary, because just think about it. If we have a problem constructing an AD account, we're going to throw an AD account invalid exception. That's easy to debug, that's easy to handle, it's easy to understand. What's not easy to understand is an index out of range exception. That's not as clear to us as what's actually happened. All right. Back to the slides. Okay, so key points. Avoid using data annotations. Use value objects where appropriate. Just think, is it really a primitive type or is it a more specialized object? Initialize all collections and use private setters. Create custom domain exceptions because they're going to be a lot easier to debug. Now we're going to have a look at the application layer. And this is my favorite section of the talk. In the application layer, we're going to see interfaces, those interfaces and abstractions for what we will implement in the external layers. We'll see models, view models, and DTOs. We'll see logic. This will be our business logic, the special cases that we're handling in this application. We'll see commands and queries. We'll talk about that soon. And we'll see validators. And, of course, application exceptions, custom exceptions that we create for this application layer. So CQRS. So everyone knows that CQRS stands for Command Query Responsibility Segregation. And with CQRS, we separate our reads from our write. And the benefits include maximizing performance and scalability. However, that's not the most important thing to me. For me, CQRS is about simplicity. When I use it, my system becomes easier to understand. And it's easy to add new features because we can just create a command or query, and it's easy to maintain. Our changes are only typically going to affect a single command or query, and hopefully we're not going to introduce side effects or bugs as a result of changing a single command or query. If you like CQRS, you will love Mediator. They're like the perfect couple. Actually, I first heard about Mediator in 2017. A good friend of mine, Brendan Richards, who's here today, actually said to me, I found Mediator and it's awesome. And at that time, we were injecting all of these commands and queries into controllers, and we were fine with that. But then he said, Mediator is awesome. We can actually replace all of that injection and just inject the iMediator interface. And I looked at it and I said to him, I don't like that. That violates the explicit dependencies principle. But then Steve Smith, who was a really cool developer, told me about it. And I thought, well, he created the explicit dependencies principle, so I went with it. So sorry, Brendan, I had my blinkers on that day. So with Mediator, we define our commands and queries as requests. The application layer then just becomes a series of requests and response objects. And with that, we gain the ability to attach additional behavior, especially around cross-cutting concerns. So we can add logging, validation, and caching with Mediator. Let's have a look at the application layer. All right. So we'll start by looking at the customers folder, just so we can see a number of commands and queries. I will zoom in. Let me get to the place. Okay. So you can see here we have a number of commands and a number of queries. And it's really easy with this structure to see what is inside each folder. And without diving in any deeper, you already know. That's one of the great things about it, how it's simplifying the overall design. Let's take a look at the create customer command first. So the create customer command, I'll zoom out, is a DTO, and it's of type Mediator iRequest. And basically, it contains everything that we need to create a customer. And using the create customer command, we also have a handler. And this is of type Mediator iRequest handler. So it's a request handler for a create customer command and returns a unit, which is saying this command doesn't return anything. If we look down, we're just injecting the things that we need. So in this case, it's the context, the notification service, and Mediator, and we use all of those things to create the customer. This is actually where we orchestrate the business case. What the business has defined needs to happen when we create a customer. So you can see we're adding it to persistence, we're saving the changes, and we're publishing a new customer created event. And later on, we can actually have a look at that now. So if we have a quick peek at this event, we can see the customer created event just sends a notification that the customer has been created. So just to be clear, each command and query encapsulates a specific business case, contains all of the logic that we need to orchestrate that business case. Okay. Now I want to talk about data annotations at the application layer. So you saw them here in the create customer command. And why would we have them there? We might use it for validation. But I found that while data annotations is fine for validation, we can do our model state checks, and that's great. It's a pretty nice experience. It's not very good for complex validation. What is good at complex validation is fluent validation. So we can take out all of these data annotations and just use fluent validation to achieve the same result. And fluent validation wires straight into the ASP.NET Core validation pipeline, so we're still going to be able to check model state, or if we're using newer versions, such as ASP.NET Core 2.2, it can do it automatically for us. So we can remove those out. That makes our DTO nice and clean. And then I'll show you the fluent validation validator. So we have a customer, no, it's a create customer, create customer validator. There we go. And so that's it. So you can see for the create customer command validator, it's still a simple case, but let's have a look at one that's not a simple case. So I have an update customer command validator. And this is where we actually have validation, which is dependent on other fields. So you can see here, this is a rule for the postcode. It must match 4 digits. That's the format of postcodes for Australia. So basically, if it doesn't match 4 digits, it'll return the message Australian postcodes have 4 digits. And then we have another rule for the phone. Must have a Queensland landline when the country is Australia and the postcode starts with 4. And you can see there we're calling a little helper function there. So that's what must have a Queensland landline is. So that's the good thing about fluent validation. And why we don't need data annotations. We can use fluent validations for our simple validation scenarios. We can use it for our complex validation scenarios, and it wires right into the ASP.NET Core pipeline. Okay, and we talked about the architecture being independent of infrastructure and data access concerns. And I just want to have a look here. So if we were to add interfaces and abstractions, it goes right into the application layer, and I've got a little interfaces folder here. So you can see here I just have one single notification service at the moment. And this notification service just has a single method, and it also has a DTO. And you'll note that the DTO is also coming from the application layer. So yes, we have these external concerns, and they come with their own DTOs. So a messaging service that we're using probably already has a messaging class that we can use. But if we bring that into the application layer, then we're creating a dependency on that external concern. So we actually have to create the interfaces and any DTOs that we'll need to communicate with that service. And later on, if we need to switch out that messaging service for something else, if we're going from SendGrid to something else, well, that's not going to be a problem. We'll keep our interface, we'll keep our DTOs, our unit tests won't change, it'll just be that service that changes, just the implementation. All right, so key points. Using CQRS and Mediator simplifies your overall design. I'm a big fan of CQRS and I really love using Mediator. Fluent validation is useful for all validation scenarios. We don't need data annotations in our domain model. We don't need it in the application layer. Mediator simplifies cross-cutting concerns. I didn't show you that. That is one of my favorite parts. Let's go back. One sec. Okay, so we talk about cross-cutting concerns. So remember that in the application layer, because we're using Mediator, all commands and queries are just requests with responses. So we essentially have a pipeline there, similar to ASP.NET Core middleware. And if you look at how we can use that, in infrastructure, I have these 3 request behaviors. Zoom in a little bit. So I've got a request logger, a request performance behavior, and a request validation behavior. So one of the things that we normally do in ASP.NET Core is to validate our models. But the thing with clean architecture is we're not necessarily always going to have a web front end. Maybe we have a console UI and we want to apply that same validation. So while we could write it again, it's actually better just to use a Mediator request validation behavior because then we get it at the core level and for any application that executes that command or query. So let's have a look at how simple it is. So you can see here that I've got a request validation behavior, and it is a generic type with a T request and a T response. And it comes from Mediator's iPipeline behavior, the same types. And you can see here the implementation. So how does this work? So the T request would be something like a create customer command or a get customer detail query. And what we do is we search the assembly to see if there are any validators associated with that DTO, the command or query, and we run them. If there are any errors, we throw a custom application exception which contains the errors. And we'll go a little bit deeper. And all the custom application exception does is put all of the failures into a dictionary, a string representing the field that has failed, and a string array representing the messages, because there might be multiple failures, so there could be one or more messages for that particular failure. And with that, if we have a look at the presentation layer just quickly, I'll show you how it's used, because it really puts together the whole experience. So I have this custom exception filter, and essentially, if there's an exception, which could happen in the application layer, and it's a validation exception, then it catches that exception and automatically returns a bad request with all of those failures in exactly the same shape as it would be if it had been returned from model state. So we get the same experience. All right, back to the slide deck.
Can you show the controller how it's actually used?
Yes, I can. The wonderful thing is, we'll go to the customer's controller because that's the example. We don't do anything. And we're going to look at this in more detail. We don't have to have any validation handling in the controller because we've implemented it in core. And what happens is this filter, this custom exception filter, actually fires if there's an exception within the action and takes over the response type. So it actually says, oh, there's an exception, I'll catch that. It's a validation exception, as you can see here, and I will set the response to bad request, and I will return you a JSON result, which is the validation failures. So you see, we don't have to handle it in the controller. And we also, well, we would, if we wrote a console application, we'd want to catch that exception in some way. But this is how we're catching it in the case of ASP.NET Core. Good question. All right. Key points using, well, we've covered those too. So Mediator simplifies cross-cutting concerns, and the design is independent of infrastructure and data access concerns. So you notice me using a DB context in my commands and queries, and you might be thinking, well, it's not independent of data access because we're using EF Core. Let's talk about that now. So in the persistence layer, we're going, especially if we're using EF Core, we're going to be using a DB context. We'll have migrations, configurations, seeding, and abstractions. So if we're implementing maybe the repository in the unit of the work, that would be an example. So the big question, should we implement the unit of work and repository patterns? So show of hands, when we're using EF Core, who thinks we should? Okay, there's maybe like 7 people. Show of hands, who thinks we shouldn't? Okay, maybe about 20 people. That's not everyone, but that's okay. That's an indication. So I think it's not always the best choice because EF Core insulates your code from database changes. How does it do that? Well, EF Core is one big abstraction. With EF Core, we choose a provider, SQL Server, Oracle, Postgres, and by changing out the provider, we change the database that we're dependent on. So we're not actually dependent on a specific database provider. We can switch that out. Sure, we might need to delete our migrations and recreate an initial migration that's specific for the provider that we're chosen, but hopefully not much more than that. Also, if you like the unit of work, well, that's good. DB context is a unit of work, and if you like the repository, that's good too. DB set is a repository. One of the things that was common to use a repository and a unit of work for in previous versions of Entity Framework was for unit testing, and that was a really good use case for repositories at that point. But now we have great testing tools. So we've got the EF Core in-memory provider, yet another EF Core provider. We can switch that in for our unit testing. All our unit tests will run in memory. But what do the experts think? So first we have Jimmy Bogard. He's the creator of AutoMapper, Mediator at the conference this week. And he thinks I'm over repositories and definitely over abstracting your data layer. So he's against repositories. We have Steve Smith, Microsoft MVP and longtime regional director, and he thinks you don't need a repository, but there are many benefits and you should consider it. Now, Steve has talked and blogged for length about repositories, and I think when he says that, he's being diplomatic. I think he's against repositories. But if you like repositories, the good news is he has a lot of great information on how to build really good repositories using the specification patterns, so check that stuff out. Finally, we have John Smith. So he's the author of the new book, EF Core in Action, and he thinks, no, the repository/unit of work pattern isn't useful with EF Core. So he's against repositories too. So what should we do when all of the experts don't agree? We take it back to basics. We realize that repositories and unit of work are design patterns. They're designed to solve a problem. If that particular pattern solves a problem you have, then you should use it. If it does not solve that problem, then you'll just be introducing unnecessary complexity. So that's the only thing you need to remember. Let's have a look at the persistence layer. All right, so the first thing that I want to show you, if I can scroll, let's contract. If we look at the CS proj, we can see that we're independent of the database. I can switch that provider out for Postgres, and we'll still be able to use it. With this particular solution, we have switched it out with Postgres, and it didn't impact anything. It's not always going to be the case, but at least we're off to a good start. Now, the next thing that I'd like to say is to prefer fluent API configuration over data annotations. So we mentioned before that we could use data annotations to help with the mapping from our object model to our relational model, but we can also use fluent API configuration. And that's just a better choice because then we're not cluttering our entities with those data annotations. And in actual fact, you can do more with fluent than you can with data annotations. Let me load up one because I want to make another point on that. So in the customer configuration, you can see that we can describe all of those properties that we would have used for data annotations. But it's really important to know the conventions when you're working with any conventions-based framework, because in this case, we're actually specifying that, well, actually not in that one. I got a better example. Order configuration. So in this particular case, we're defining that order ID is a primary key. But if we know Entity Framework well, we know that if there's an entity named order and there's a property named ID or order ID with a varying case, it already knows it's a primary key. So yes, use entity type configurations, but know your conventions and make your life a little bit easier. But that's true of any conventions-based framework. If you know the conventions, it'll be easier to work with it. One other thing, with all of these configurations, there are a few different ways to apply it, but fortunately in EF Core 2.2, we now have a new method, and it can apply all of those configurations automatically for us. So we used to have to say model builder.apply configuration and new up the configuration, always forget, and that would catch us. But now we can just run that, so that's quite good. That came in 2.2. All right, so key points. It's independent of the database. We're using the EF Core providers, and so we're kind of safe. We use Fluent API configuration over data annotations. They're more powerful. We prefer conventions over configuration. We know our conventions, and therefore we're more effective when we design our systems. And we automatically apply all entity type configurations using the EF Core 2.2 apply all configurations method. All right, now let's have a look at the infrastructure layer. So in our infrastructure layer, we have implementations. It contains classes for accessing external resources. So for example, it could be API clients if we're communicating with some other web API, file system if we need to access the file system, email, notifications. The system clock is a good one. You might think, datetime.now is pretty safe in your code, but if you've got any kind of logic that's based on the current date and time, you need to abstract that. Otherwise, it's going to be hard to unit test. Really, the infrastructure layer contains anything external. When we talk about infrastructure, we really are talking about persistence as well, but it makes sense to split them up. And how many, in this solution, there's one infrastructure project, but it really depends on the complexity of what's going in there. If you're implementing security, that's probably going to be an entirely separate project, but it'll go into the infrastructure layer. So let's have a look at the infrastructure layer. So I don't have too much in the infrastructure layer for this particular example. I do have an implementation for machine date time. So you can see that's quite simple. But when we go to unit tests, we can substitute idate time with something else. So say if we had some logic that was dependent on a Tuesday, this particular logic only fired on a Tuesday. Well, we can substitute in an idate time that tells the test that it's a Tuesday. So it's as simple as that. Actually, we had another nice benefit in a project that I was involved in. Because we had that idate time implemented really well throughout the system, we're actually able to provide the front-end testers with a new tool. They could adjust the system date time using a menu item in configuration so that their testing was more effective. They could actually move it forward and move it back and set it back to actual system time. So that was good for them, for the exploratory testing. We also have the implementation for the notification service. It's a bit lightweight, but it's really quick. So this is the notification service that we saw earlier in the application layer. So it's using the interface from the application layer, and it's using the type from the application layer. So whatever we put in here is going to be external of core. So the other important thing, and we mentioned this at the beginning, but it's important to mention again, is that no layers should depend on infrastructure layer. It doesn't have any dependencies. It depends on core, but nothing depends on it. Because as soon as, and I've seen this before, and that's why I'm saying it again, if you have a dependency going from presentation to infrastructure, then things start to break down because you have to create that logic inside of presentation, and that logic can't be shared by other applications that are connecting to it. All the dependencies point inwards. That means all the logic will be orchestrated within core. That means any UIs that you add to it later will benefit from that logic. All right, so key points. So the infrastructure layer contains classes for accessing external resources, so such as file systems, web services, SMTP, and so on, anything external. It implements abstractions / interfaces defined within the application layer. and no layers depend on the infrastructure layer, e.g. presentation layer. So finally, we're going to look at the presentation layer. So as I mentioned, this is a ASP.NET Core 2.2 web app running Angular. So in the presentation layer, it can be whatever we want. It could be Spark, Angular, React, Vue, Web API, Razor Pages, Blazor, MVC, web forms even. It really doesn't matter. Everything's in Core. Let's have a look. So the first thing I want to do is take a little bit of a tour of a particular controller in this solution. It's got quite a lot of history behind it, and it's good to see kind of the evolution as we implemented these various features in the system and what kind of impact it had. Okay. I really want that. Come back. Okay. Scroll down. Oh no, this is the wrong one. Sorry. We're going to look at the products controller. Okay. First we'll look at this one. So you can see here, this is a really typical controller and something that you've seen many times before. We have a products controller, and into this controller, we inject the DB context. We're returning entities directly from the controller, and it's a trivial controller, but even so, it's quite verbose. There's quite a lot happening. There's a few things wrong with this. The first thing is that we've brought in something like the DB context, which is a really low-level concept, as something that's really on the edge of our architecture and design. So we only have one place left to put the logic, and that's in the actions of the controller. Now, we can't really share that. We could get crazy and maybe start referencing controllers in console apps and stuff and share it that way, but that's not going to work. Nobody's going to do that. The other problem we have is we're returning entities, and entities are another really low-level concept. You know, we need to return view models because when we return a product, maybe we're going to edit that product. There's not enough information in a product entity to actually edit a product. We need a list of suppliers. We need a list of categories. We need all sorts of information. That's why we typically return view models. Not too much else happening here. We've got some checks and bits and pieces of logic. Let's move on. History. It's customers controller. There it is. Okay. I think this one. So this is where we were using commands and queries before I started listening to Steve Smith. So we're injecting all of these commands and queries, everything that the controller needs. And the good thing about that is we're no longer returning entities, and we no longer have a dependency on the DB context at this level. So we are able to encapsulate our logic within a specific query or command, and we can encapsulate whatever we need in the DTO or view model that we return. Then we found out about from services. From services is really cool. So it's just a feature with the dependency injection built into .NET Core, where we can actually inject at a method level the thing that we need. So you can see here for this post-product action, we're injecting a iCreateProduct command, and we can use that to execute the command. And you can see, even at this stage, this controller is starting to get quite concise. There's only 1 or 2 lines of code, and there's certainly no logic within there. So it's a big improvement. And then we started using Mediator. So with Mediator, we're injecting iMediator, and we don't need to actually inject the commands and queries anymore. It's all wired up. We saw the commands and queries were implementing iRequest, Mediator requests, and the handlers were implementing iRequest handler. So you can see things are really simple. We're just executing queries and executing commands. Oops. Let's see, there's been lots of changes. Let's just go to the latest one. So this is what it looks like today. We're not even injecting Mediator. We have a base control to take care of that for us. You can see here that it's quite simple. We don't really need to do too much, and that's wonderful. Our controllers have become a piece of infrastructure. Their responsibility now is to take a request and to turn it into a response and nothing else. All of the logic behind that request, all of the processing, the orchestration that we need to do is handled elsewhere. Question?
Yeah, where does the TTO object lives in this architecture?
In the application layer. Yeah, that's a good point, and a point that I didn't make. You have only good questions, thank you. Let's find that. So, actually there's 2 points. So when we looked at create customer, what you may have noticed, sorry, I'm just zooming in, is everything that's associated with creating a customer is in the same folder. So if we do need to change the create customer command, we're not going to be jumping around to different folders to do that. Everything is there. We have the command itself, the DTO with which we make the request. We have the handler, the class that's responsible for handling the request, and we have the validator, the class that's responsible for validating the DTO. And then we have our customer created event. So it's all there. That's a really good way to organize your files. So the DTO is there. If we have a look at products, actually the queries. There we go. So there's our DTOs, all located together with the queries or commands. And you might think, well, I want to put them in a central location and I want to share them, because I use products in more than one place. And that can be the case. The problem with that, however, is usually there is some difference in the way you're using product. So for example, you might want a list of products and you might just want the ID and the name. But of course, when you're editing a product, you want kind of the full DTO. Now, if you start reusing those models, what can happen is you can introduce side effects. So you go to change one query or command and you break another query or command. So I think it's better to not reuse the DTOs unless they're absolutely trivial, and to keep them separate. So that way when you change one thing, you don't have to worry about side effects. Let's see, there was one other point I wanted to make. Oh yes, one of the things that new developers will often complain about when they first start working with CQRS is discoverability. If we go to, let me zoom out, that's not zooming out. If we go to the customers controller and we have a look at the commands or the queries, it's easy for us to jump directly to the query. We can just press F12 and we're there. But it's not easy for us to jump to the handler, and that's really where we want to go most of the time. So there's actually an alternate approach that you can use. So instead of creating separate commands and command handlers, you can take the handler, the class, and nest it directly into the command. And that's actually my preferred approach. In fact, if I undo the changes, where is that? I will go Team Explorer, changes, there. So now we have the create customer command, including the handler. At the top, we have all of the properties that are associated with this DTO. Then we have the handler and the implementation for that handler. So maybe you like that, maybe you don't, but it's one way to do it, and it does improve discoverability. So now when we go from the controller to the create customer command, everything that the developer is expecting to see is there. So I think that's kind of nice. Okay, next thing that I want to show is OpenAPI. So I think everyone has heard of OpenAPI. If they haven't, then they've heard of Swagger. So we won't go into that. But I want to show you the particular implementation that I'm using. And I find it really useful. I've gone through a number of different variations. So I'm using NSwag. And you can see here, I have an NSWAG configuration file, and this particular configuration file, without going into the boring details, will do two things for me. First, it will create the OpenAPI specification document so that other systems can interact with my system. And the second thing it will do is to create an Angular client so that I can automatically interact with my backend API from Angular. And what it creates for me is something quite wonderful. It creates all of the services and all of those DTOs or view models in TypeScript. I don't have to create those myself. It saves me a lot of time. And I found that the code it produces is exceptional. And that's what you want. The source of truth is in that application layer, in core. We don't want to recreate them from scratch, which is what we used to do in the past. We want them to be generated based on the source of truth. And this is so effective. You can see in my web UI, if I edit the CS project, I have an MS build task which will actually run NSWAG from the command line and generate the specification and generate that Angular TypeScript client whenever a controller changes. So whenever anything changes, it's automatically rebuilt. Now, if you've been developing with Angular, you know that Angular will automatically pick up those changes as well. So if something changes in your web API that causes a breaking change, Angular is going to pick it up straight away and it's going to tell you. So it's a really nice experience. And with NSWAG, of course, we have good tooling. So we have the NSWAG Studio, and we can use it to generate a number of things. So this is I'll zoom out, and we'll have a look at exactly what we're generating for this project. I think that app is running too. Well, we can have a look here. Okay, so this is the specification. That gets generated on build, and it gets actually put onto the file system. You can do the generation of the specification at runtime, but I find that problematic because at runtime we have to deal with things like permissions and authentication. So you can see the specification is just plain JSON. It's not really for us to read. There's the TypeScript client, and you can see TypeScript client's really great. It's really long. It contains all of the services, so you know we have a products controller, so there's going to be a products client, so we can access all of those methods. But I want to show you a DTO. Here's an employee manager model. So that's the type that exists in core, and it's been recreated for us in TypeScript, ready to go. And of course, we've got Swagger UI in the background, so that makes it easy for developers to work with our system. They can see and explore our API. They can try out methods if they want to, which is great. There we go. Nice and easy. So it just gives us a number of advantages. Really, what I like to say is that OpenAPI, no matter which tool you're using, bridges the gap between the front end and the back end. Oh, where's my slides? All right, so key points. Controllers should not contain any application logic. We've worked really hard now, and all of that logic has moved into core where it belongs. We should create and consume well-defined view models. Entities are not sufficient to return to the client. We need something more specific based on whatever command or query is related to. OpenAPI bridges the gap between the front end and the back end. So I have some recommended resources. The first one, this is a book by Steve Smith, Architecting Modern Web Applications with ASP.NET Core and Azure. This is a great book. It's a quick read. This is where I first learned about clean architecture. One thing I'll say, if you're not into Azure, don't worry. That really doesn't impact the content of the book. It's excellent. And I'll share a link to the slides and code as well. Next one is Building Microservices. This is really a companion book to the first book, and keep in mind, if you're not into containers and you're not into Azure, that's okay. All of the content in this book is still really relevant. I'd highly recommend, if you like what you saw today, those are two really good books to get started with. And of course, we have Clean Architecture by Uncle Bob. It would be amiss of me not to mention the book that was published on this. So, thanks for coming to my talk today. If you're keen to learn more, please download the code and slides, and try it out for yourself. I think you're going to find that clean architecture is simple to implement all the way from development to production. Thank you. Cheers. Happy to take any questions. Yes?
Going back to the repository.
Yes.
I think you were right to say it depends on the context, because we were assuming that you always get your data from a database. But if, say, you had a choice of getting it from